Let's talk about a problem that many of you have. You need to access your player character in a class, but don't have access to it because you're creating it in a different class. Here I'm trying to access my yellow bird in the controller class that handles keyboard input, but I can't because I'm creating the bird in game world class, so I don't have access to it. Initially, when we started writing our first game, we dumped everything, that is the creation of the world, the view, platforms, bird, everything in a single class, and even more so in a single method. Because everything was in the same method, all our code had access to all our variables, fields, and objects, so things were easy. Then we started splitting off this code into multiple different classes. We put the creation of the scene in game world, the functionality of our character in yellow bird, the keyboard handling in the controller, collision handling in pickup, and so on. So now suddenly we have variables and fields and objects in one class and code that needs to access them in another class. So then, how do you get access to an object created in a different part of your code, perhaps in a different class? First, let's see what happens when you create new objects. I'd like you to think about your code and where objects live as two different spaces. This is where you write your code. Think of it as NetBeans or Java code files. And this is where objects get created, a part of your computer's memory dedicated to running your program, your game, called the heap. Things are in fact a little bit more complicated. There's a different part of computer memory called the stack that also plays a major part, but let's keep it simple for now. So, when we write this bit of code, what happens? Does a new world get created in the computer's memory? No, not yet. We are creating a world variable, but we are not yet creating a world object. The distinction is very important. This only exists in code. Now, what happens if we write this line of code? Now a game world object gets created in the computer's memory. The problem is that while these two lines of code are valid, they're pretty useless as written. This is because, yes, we've created an object in the computer's memory, but we have from this point on no way of accessing it or referring to it. We also have a variable that is by default referring to nothing, to null. Instead, we'd like to be able to use our world variable to reference this object in memory. In other words, we want to create a link between our variable in code space and the object in memory space. We want this. We are attaching the reference to the game object to our variable. So now our world variable references the game world object in memory. What happens when we call this new game world method? In addition to creating an object of type gameWorld in memory, the constructor of this object is also called. This is the method that looks like this in the gameWorld class. You notice that in this constructor we populate our game world. Among other things, we create our player. We've done this by first adding a player field in the game world class over here, and then writing up this line of code. But let's first imagine that this line doesn't exist. What object in memory does player reference? No object whatsoever at this point, because the default value for reference fields are null. This is why we add this line. Now the new yellow bird bit creates a new object in memory, and then the equal sign links a reference to that object to our player variable. But notice again the distinction between our variable or field and our object. They are not the same thing. The variable is simply a way to refer or to access the object. As we will see, you can have many variables or fields that refer to the same object. Okay, stepping back and hiding this game world Java file. Assuming we've created the world, let's go on to create a new controller that handles keyboard input and moves our player character about. So we write this line of code here, and notice what happened. We are declaring variable C of type controller, then we are creating the object of type controller, then we are linking the variable C to the reference so as to reference the newly created object. Now, within our controller, we'd like to do something like this. Jump our player if a certain key was pressed. And when we do this, we envision that player should refer to this yellow bird, the same yellow bird that we created in the world. Yep? As it is though, it doesn't work because we have no player variable or field in our controller. Right now that only exists in the game world. So, what are some possible solutions that you envision? How about we write this? Body player equals new yellow bird, right here. Now we've created a new variable called player in controller and we can access it over here. Yay! What's the catch? What this line of code does is creates a new yellow bird in memory. Every time you call new, you use this keyword, a new object gets created, different from the ones you've created before. So this player, even though it has the same name as the player in game world, refers to a different object in memory. That's no good. We want this initial yellow bird, not this new one. So how about instead we add a field called player in the controller class? Will this work? Well, right now no new object was created because we didn't use the new word. We just create a player field, but no object with it. This also means that by default our new field called player references nothing or null. But that's not good either because we'd like our variable to reference an actual object, a yellow bird. We could add this line here, but again this will create a completely new object, different from the one before. And it will link our field player to that new object. Instead, obviously, we'd like this field player here to reference the yellow bird from before. Okay, so let's remove that line. And instead, we are going to add this controller constructor. Notice how the name of the method is the same as the name of the class, hence this is a constructor. And this one is the same as this one that gets called over here. Our constructor has a parameter called, again, player, and in its body we do this. Before we move further, I'll remind you that variables are defined by name, type, and scope. Yes, scope. So, notice that our code now has 1, 2, 3 fields or variables called player, and they're all different. This is the player field that exists in game world, this is the player field that exists in controller, and this is the player parameter that only exists in the controller's constructor. I'll now focus on these two. They are also very different. The player field is visible in the entire controller class. The player parameter is visible only in this method's body. The problem is that in this constructor, both are visible or accessible. That's not the case in other methods. For example, in keyPressed, if we type player, like here, then we can only refer to this one, because only this one, the field, is visible here. This one, the constructor's parameter, is not, because it's only visible in here. But in the constructor, we can access both. So how do we differentiate if we mean this one or this one? The convention is that if we write just player, then we mean this one, the parameter, and if we say this dot player, then we refer to the field of this object. Okay, so now we have the player in the game world referencing the right yellow bird in memory. Let's assume we can access that field in game world and plug it in here. It's important to realize that this here, world.player, and this here, the player in the world, are exactly the same variable. I'm using this dot notation to access directly the field in my game world object. So, since it's the same, this expression here references my correct yellow bird. Now, through this constructor call, this reference gets copied onto this parameter here. It gets copied. So this and this are not the same. This is the world's player, while this is the player that exists only in the constructor. The value of the world's player, which is the reference to my bird, gets copied to this parameter. So their values are the same, but the two variables or fields are different. Good, so now this parameter in here references the correct bird. Then that value, the reference to the yellow bird, gets copied further to this player, which is the field of the controller. And now this field also references the correct bird. And since this field is the same throughout the class, this now points to the right place in memory. So, we had a player field in game world, which we accessed directly in here, then copied that reference into this player parameter, which is different, in the constructor by doing this call, and then we copied the same reference from that parameter into the player field of the controller, which is also different. And now we have access to that reference everywhere in the controller class. So see how we had 3 different variables or fields all accessing the same yellow bird in the computer's memory. Good. There's just one more glitch. The compiler won't let us do this. That's because the player field in the game world is private and we can't access it directly from outside the game world class. That's okay though. We can create a public accessor or getter that lets us access the field indirectly. And now this works fine. So, notice how we can access fields upstream, that means from classes that contain other classes, by using getters or accessors. Then we access fields and variables downstream into classes contained by other classes by passing the values of these variables or fields through constructors. But again, notice that all of these are different variables or different fields. They exist in different parts of the program. And you can do this no matter how far away your code. Think of your code as an upside-down tree with classes contained into other classes branching down. You can pass values of fields up from the example, for example, the player or an enemy towards the root of your code, which in our case is generally game.java, and then down on a different branch, for example, towards the keyboard controller. And so you can access any variable or any field anywhere in your program.